vocabulary lesson 8.3 is cross sections. Those of you who are really good at imagining in your brain three-dimensional sorts of things and how they would cut into pieces, like if you were to slice through a rectangle or slice through a triangle, you will be very good at this. Those of you who are like me and have a hard time visualizing it and really need something to actually do that with, yeah, it's a little harder, but just be patient with yourself and you will do fine. For the most, you'll get most of them. Some of them you'll just, your brain will have a hard time seeing it. So don't worry, you'll do fine. There's a lot of vocabulary, or at least 3 pieces of vocabulary they talk about in here, so I'm going to start with that. All right, so first vocabulary, intersection. Well, it's where 2 things meet, and you know that already, so that's not a new word to you. A plane, in this case, it is spelled the same way as airplane, but they don't mean an airplane. A plane, in terms of geometry, is a flat surface that extends forever in all directions. And this blue square in your book on all of these is representative of that flat plane. Obviously, it doesn't extend in all directions because the book doesn't go in all directions forever. So in our world, there are limits and not forevers. So they drew it as that. But this is kind of that plane, the part that's going to be cutting through these 3-dimensional objects. So think of it like the knife that's going to be cutting through our 3-dimensional objects. So that's the plane, the blue part of this in the model. And then the cross section, that's the intersection of the flat part where the plane is at and the 3-dimensional object, the cone. So like if I cut this plane right through here and then I lifted this part up and turned it toward me, the cross section would be this flat part right here, which would be in the shape of a circle. And so in this lesson, they're going to be asking us things like, at the intersection of the plane and the cone, what shape, what's the cross section, the shape of the cross section you would get? So you would imagine in your brain, okay, so if I sent this plane through this cone, and then I lifted up the top of that, then I would see a circle. So the answer would be circle. That's it. That's what this lesson is doing. So it's not a calculation sort of difficulty, but for those of you who are like me and the visual part is sometimes difficult, depending on, like this one wasn't too bad, but some of them can get difficult for me. Just be patient with yourself. You'll be fine. Okay, so here's a few more examples. If I have this triangular, the face of this prism is a triangle, so we call it a triangular prism. If I have this triangular prism and I'm going to cut through it with a plane from top to bottom and then pull this part of it away, the cross section would be the face that I would be looking at where it was cut, and that shape would be a triangle. So cross section would be triangle. On this example, if the plane intersects with the 3-dimensional object, this is a rectangular prism. And it's this time the plane is coming through on an angle here. So if it cuts through this corner right here, and I pull this little piece off of there and look at the part where it was cut, the face of where it was cut, you would see a triangle. And on this one, I have a rectangular prism, and the plane comes straight through. And so if I lifted this top part and looked at that part that was just cut, what shape would it be? Right, it would be a rectangle. Okay, a couple more. This is a rectangular prism, and I have the plane slicing through at an angle. The angle part is where I struggle with. It's when it's coming through at angles. Sometimes it's clear enough, and sometimes it's not. This would be not a rectangle because you're going to have some angles that are not 90 degree on that. So this one would end up being a parallelogram if you looked at the face of it. This is one of those ones that I would have had an easier time if I could have like a stick of butter and then cut through it at that angle and look at it. But if you were to look at it, you would see a parallelogram because your angles aren't going to be, so parallelogram looking like this. Your angles aren't going to be 90-degree angles, so we can't call it a rectangle. All right, this one, nice and easy. It goes straight through. This looks like it's probably a square. So this square prism thing going on, if I were to cut this plane straight down, I would have a square. And if it wasn't a square, if I didn't have perfect sides being the same length, and if it was in fact a rectangle, it's hard to tell, it doesn't say. So if this is not a square and this is a rectangle, then sliding straight down would be a rectangle as the cross section. This asks a question, is it possible to have a circular cross section in a right rectangular prism? In these rectangular prisms, is there any way we could cut it with a plane that would give us a circle? And no, there's not, right? Because there's no arcs, there's no curves in this in order for a circle to happen, and circles need to have a curve. So you can't cut this in any way that's going to give you a circle of any kind. So that would be the answer to that. Let's look at the next example. Okay, so they describe to us a right rectangular pyramid with a non-square base as shown. So here is what they have shown. That's a rectangle at its base on the bottom that it's sitting on, not a square. So rectangle down there. And then it's a pyramid coming into one point at the top. In a right pyramid, the point where the triangular sides meet is centered over the base. So it's at the center. What is the shape of the base, the butt that this is sitting on right there? They even said a non-square, so it's a rectangle. And then the shape of each side. There's a side, there's a side. What shape is each side? Right, it is a triangle. So now they ask us, what do you think? Can it have a square if you cut it? Remember, this base is rectangle, not square. So even cutting it straight through, I'm going to end up with a rectangle. And if I come in at an angle in any way, that's even going to elongate that rectangle even further. So to get a square with all the sides the same, I'm not going to be able to pull off. Can I get a rectangle? Yes, because if I just cut it straight across like that, I am getting the same as his base, only a little bit smaller, right? So that would be a rectangle. So we have a no for square and yes for rectangle. Can I get a triangle? Well, this example over here shows them getting just that. If they took the plane straight down through to the bottom and then pulled this apart, you would see a triangle. So yes. Can I get a circle? Do you see any curved edges anywhere here? Yeah, then no, I can't get a circle. And can I get a trapezoid? Remember, a trapezoid is like a triangle with its head that got caught in a mouse trap and got cut off, right? So this would be a trapezoid here. So can I get that shape? If you take the plane and you cut it, but you don't cut it from the top, you bring it just straight down at the middle of it and then straight down to the bottom. Take a look at the shape that results from that. So yes, I can get a trapezoid. And in the reflection section, they ask, well, suppose the figure in B had a square base. So let's suppose there was a square base instead of a rectangle. Would your answers in B be the same? So if this was a square, could I get a square? Yes. Could I get a rectangle? Yeah, I could if I came at a diagonal, probably. Could I get a triangle? Yes, I could still get a triangle. Could, if it was done like this, I could still get the triangle. Could I get the circle? No, because no curves. Could I get the trapezoid? Yeah, I could still do the same thing. So the only one that changes is square. Now I would be able to get a square. So anyways, in this lesson, you're just really trying to visualize. They will show you or tell you how your plane is cutting through the three-dimensional object, and you will have to visualize what shape you will get. So you get those visual screens in your brains turned on and ready to go. And good luck. I know you've got this.